start process. Okay. So I will go on to, where is it? Wave refraction, diffraction, reflection, and wave run-up and sediment. Okay. So wave is very popular idea. Even for the electronic waves, as we are using for my smartphone, right? Telecommunication. So there are so many, and sound also is a wave, but we are seeing the water waves and caused by wind and wave refraction. As wave is coming toward the shallow water to the land, the speed of wave is slowed down because the depth is decreased because of the, what is it say, resistance from the soil bottom, right? And finally, at the beach, the wave is breaking. Right? So you can expect that tsunami is very high big height of wave, but in deep ocean, they are not so high. Even the tsunami, they cannot see even in a big ocean. Instead, they have a longer length of the wave. So here in the picture, you see that the wavelength is L in deep ocean, and there is a speed of wave in sea. But as wave is coming toward the land, the length is shorter, and also the height can be more sharper, not round. So it looks like bigger and crest and break. And you see that there is a equation called D equal L by 2 divided by 2. That is the usual differentiating line between what is the deep water, what is the shallow water. So this is L is a wavelength. So half of the wavelength, if we have a depth of half of the wavelength, then we call this is a deep ocean. And then the wave does not have any change of speed or crest shape or break. And at the right-hand side, you see that depth is about 20 of length of the wave, then usually the wave is breaking. Okay, so that is the rough criteria. And one more thing you should use of this kind of simplification, that when there is a storm is coming, there are so many fish farmers around the world. Even in Korea, there are so many fish farming businesses. And many people are using a cage of fish, which is floating near the beach. But once the storm is coming, hurricane or typhoon, then they are very dangerous because the cage can be break and fish is far away, escape. Right? So in that case, you can have the solution that if somehow the cage can be submerged to depths of half length of the wave of tsunami or hurricane, then the cage can be safe because there is no wave disturbance. Depths more than depths of half of the length of the wave. So there are people already which has the cage which can be submerged. So to the depths of somehow. Because the length of the wave can be 10 or 20 something. So that you may think about 10-meter depth of the submergence. It can be a good solution. Right? So there are more complicated equations, but we will not cover this. And wave reflection. They have a bending of wave crest. So the wave reflection means, I will show you this one. This is a diffraction. Refraction is a little bit different. I should prepare a picture of this. Anyway, the wave crest has a bending. So, and also because of the speed change of the wave due to the depth, we see this. The wave speed is decreasing towards shallow water. Then, because here the depth of the water is deep, but here can be shallower. So the speed is higher here and slower here. Right? That's why they give you a bending of direction, wave crest, toward the how can I say the protrusion head of the land, and then see that there are more sediment movement. So that we expect that this protrusion can be decreased. And also you may expect a quiet beach so that the sand is deposited here. That is a usual case. So when you go to the beach, there is a rock, stones, big stones or rocks are here as a protrusion. And between protrusion, there is a curved beach with the sand. So you can see this kind of shape here. And diffraction looks like this one. So when we have a small slit, then the wave is spreading out after the slit. So we call this is wave diffraction. Then you can expect that the energy transfer more wide, spread out, and you can observe that kind of diffraction near the breakwater. This is a breakwater, which is protecting ships inside here from the high ocean, high wave outside. We call this as breakwater. Or small island. Afterward, there is a wave is spreading out toward the corner. And deflection. So you should see that deflection and refraction and diffraction and refraction, diffraction and deflection. Oh, so reflection is something like this one. Right? Reflection, reflected rays. This is for sound, also light beam, but also the waves, physical waves. So all this is a property of wave, any wave. We'll see that video. Okay.
Sun just set, and there's an incredible amount of physics to be learned. Looking at these waves and going through shallow water. What I'm looking at is waves traveling in towards the beach, and then waves reflecting out through the waves that are traveling in. Meaning waves coming in, bouncing off the beach, and reflecting back out. Now, while they bounce back out, you can see the incoming wave interacting with the outgoing wave. What do we call it when one wave interacts with another? Let me think. Wait a second. I think that's called interference.
Okay. So that's it. Oh, sorry. All right, and then wave run up. So sometimes wave is coming toward the beach so that it is more than higher than water level. Water level is dotted line. Because of the speed and wave breaking, water is come somewhere around the depth, height of R. And we call this is a foreshore and near shore, foreshore. So what water is coming up over the beach sand. So vertical extent of wave uprush over the water level. And we can observe that kind of thing in beaches and coastal protection structures. So when you installing or designing ocean structures near the coastal area, you need to think about how to handle this kind of phenomena. And sediment, the sand, beach, there are different kinds of sediment is deposited there. Somewhere there is rocks are there. And Pebble Beach is famous near the San Francisco, United States, California. And there is a very nice golf club, Pebble Beach. But the beach has the pebbles, stones, rounded stones. Not here in the picture, but anyway. The stone of some size can be deposited or also transported. And there are different sizes of fine sand, medium sand, coarse sand, and also clay. And sediment transport, depending on the grain size. So suspension. If the size is very small, then it can be stay longer inside the water once disturbed. But if the size is big, it is not easy to move them. Okay, so there is differences and classification. And you may calculate how to move a stone or pebble by water flow. So the force can be drag force from the water, and also there is a buoyancy and weight. Usually the stone is heavy, so gravity is bigger than lift, buoyancy. Also there are friction from the sediment. So the calculation can be very complicated. I will not explain this. But as a coastal engineer, you need to calculate sometimes so that you may expect what can be the sediment deposition or removal from the beach. Because of when you think about coastal structure, then the footing can be important. But because of sediment movement, transport, the footing of the structure can be eliminated, or above the water or above the sand or bottom. So you need to calculate well, because it should stay long time, 10 years or more. All right, this is a video. About sediment. Coming from our hand, engineering. you see that from the video that the size of the grain or sand is about 2 or 3 millimeter size. Right. Oh, that's it. Today's lecture is very short, even before the 2 o'clock. All right. Any questions? On schedule? No? Then we can close earlier today. And see you on Thursday. All right, bye now.
Thank you, Professor.